We all know black holes are famous for swallowing everything that gets too close. Light, gas, entire planets, but some black holes do something even more terrifying. They don't just consume stars, they rip them apart first. They stretch them into glowing, fiery streams of cosmic material before completely destroying them. These are called tidal disruption events, and they are among the most violent and spectacular shows in the entire universe. So, what exactly happens when a star gets too close to a black hole? Well, a star is normally held together by its own immense gravity, pulling everything inward into a stable, spherical shape. But when that star drifts too close to a black hole, the rules of gravity change dramatically. The side of the star closer to the black hole feels a much stronger gravitational pull than the side that's farther away. Imagine pulling on a piece of taffy. One side gets pulled harder than the other, and it starts to stretch. The same thing happens to the star. This difference in gravitational force, known as a tidal force, is so extreme that it overcomes the star's own gravity. The star is literally torn apart from the inside out. Scientists have a perfectly descriptive name for this, a tidal disruption event. It's the beginning of the end for the star. As the star gets stretched, it becomes incredibly long and thin, like a piece of spaghetti. And that's exactly what astronomers call this process, spaghettification. It's a bit of a funny word for something so cataclysmic. The star is no longer a star. It has been pulled into a glowing ribbon of superheated gas that wraps around the black hole like a scarf. As this ribbon of stellar material swirls around the black hole, friction between the gas particles heats it up to millions of degrees. This extreme heat causes the material to glow incredibly brightly. For a short time, this dying star can shine brighter than its entire host galaxy, which contains billions of other stars. It's a final, brilliant burst of light before being consumed. But here's a fascinating detail. Not all black holes do this. You might think the biggest black holes are the most destructive, but that's not always the case. Stellar mass black holes, which are only a few times the mass of our Sun, are actually too small. Their tidal forces are so intense that a star would be ripped apart well before it even reached the event horizon, but the resulting show isn't quite as grand. On the other end of the spectrum, the largest supermassive black holes, those billions of times the mass of the Sun, have a different problem. Their event horizons are so huge that a star can cross it without being torn apart first. The tidal forces aren't strong enough at that distance. So, the star just gets swallowed whole without any of the spectacular fireworks. It just vanishes. The most destructive black holes are actually the medium-sized supermassive black holes. They're in the sweet spot, maybe a few million to 100 million times the mass of the Sun. They are perfectly sized to tear a star into spaghetti right outside their event horizon, creating the most brilliant and observable tidal disruption events. So, what happens to the star's remains after it's been spaghettified? It's not as simple as everything just falling in. In fact, about half of the star's material is flung away from the black hole at incredible speeds, shot back out into interstellar space. This ejected gas can travel for thousands of years, carrying the memory of the destroyed star across the galaxy. The other half of the star, however, is doomed. It doesn't fall directly into the black hole. Instead, it forms a bright, spinning disk of material around it, called an accretion disk. As this material spirals inward toward the event horizon, it gets hotter and hotter, releasing an immense amount of energy in the form of intense radiation, like X-rays and ultraviolet light. This is the final flare, a cosmic death scream that can be seen from billions of light-years away across the universe. This brings us to how scientists actually detect these star-destroying events. We can't see the black hole itself, of course. They're invisible by definition. So, instead, telescopes like those at NASA constantly scanning the skies for the telltale signs of a star's demise. They're looking for sudden, brilliant bursts of high-energy X-rays or bright flashes of ultraviolet light coming from the center of a distant galaxy where a supermassive black hole resides. They also look for rapid changes in brightness. A galaxy's core might suddenly flare up, becoming hundreds of times brighter over a few weeks or months, and then slowly fade away. These signals are the echoes of a catastrophic event, the evidence that a black hole has just torn a star to pieces. It's like cosmic forensics, piecing together the story of a stellar murder from the evidence left behind. Now, the big question: could this happen to our own sun? Should we be worried? Thankfully, the answer is a resounding no. The supermassive black hole at the center of our Milky Way, called Sagittarius A star, about 26,000 light-years away. That's a safe distance. The chances of our sun ever drifting close enough to be torn apart are astronomically small, basically zero. Our solar system is in a stable, quiet neighborhood of the galaxy. But in other, more chaotic galaxies, this is a regular occurrence. Astronomers estimate that in a typical galaxy, a tidal disruption event happens every few thousand to 100,000 years. It might sound rare, but with billions of galaxies out there, it means that somewhere in the universe, a star is being ripped apart by a black hole right now. So, why does studying these events matter so much? It's not just about witnessing cosmic violence. Tidal disruption events are incredibly valuable for scientists. They provide a unique opportunity to study black holes indirectly. When a star is torn apart, it illuminates the region right around the black hole's event horizon, an area we could never see otherwise. These events allow us to test our understanding of extreme gravity and the theories of general relativity under the most intense conditions imaginable. We get to watch how matter behaves when it's pushed to its absolute limits, spiraling into the point of no return. In essence, these destructive events turn invisible monsters into visible cosmic laboratories, giving us a front row seat to the physics of the universe's most extreme objects. In the end, it's a powerful lesson. Stars are among the most massive and powerful objects we know. They are the engines of galaxies, forging the elements we're made of. Yet, even they can be completely and utterly destroyed. When a black hole takes a star apart, the universe lights up in a final, violent, and beautiful farewell. It's a breathtaking reminder that space is not only beautiful and full of wonder, but also incredibly, terrifyingly powerful. Thanks for watching. If you found this journey into cosmic destruction as fascinating as I did, don't forget to like this video and subscribe for more deep dives into the mysteries of our universe. See you next time.